In the next couple of chapters, we're going to be learning about statistics. The foundation of statistics is data, so we'll start by exploring data. Data is everywhere, so first of all, we want to define exactly what we mean by data. Once we do that, we want to be able to organize and interpret data so that it's more useful to us. And we're going to do that in two ways. First, we're going to look at numerical representations called frequency distributions, and then we'll look at a graphical representation called a histogram. So first, what is data? A set of data contains information about some group of individuals, and this information is organized in variables. So first, individuals are the entities described by a set of data. So here are a few examples. If I give a survey to the class, then the individuals will be the people in this class. If you see a poll on the news during an election, then the individuals are usually called likely voters. If you are purchasing a product on Amazon, then you'll see ratings and reviews for that product, and those are given by people who have purchased the product, so those are the individuals. A variable is a particular characteristic or trait that can take on different values for different individuals. So in our example here, if I survey the class, I can ask what your hair color is, and then hair color would be a variable, and it takes on different values for different individuals. So people will have different color hair. For likely voters in the poll, I could ask what their political affiliation is, and that would take on different values for different individuals. They could say Republican or Democrat or Independent. For people who've purchased a product, the variable could be how they rated the product, somewhere between 1 and 5 stars. Now you might notice that these first two variables I can describe with words, and then the last variable is described with numbers. So quantitative variables are ones that are described by numbers, and that's what we're going to be focusing on in this class. So let's look at another example. So this chart shows data from a student questionnaire. And first, what are the individuals in this chart? Well, the individuals are the students. So the chart shows information about students. What about variables? Well, there's several variables here, and each variable corresponds to a column in the chart. So the first variable asked if the student was male or female, and that corresponds to the first column in the chart labeled sex. The second variable is handedness. Is the student left-handed or right-handed? The third variable is height, and that gives the height of the student in inches. The fourth variable is study. So that's the time that the student spent studying in minutes on a weeknight. And the last variable is coins, which is the amount of change that students had in their pocket when they took the survey. So each variable corresponds to a column. And the individuals, each individual's information is given in a single row. So an individual corresponds to a row. Now notice that my last three variables here, these are all quantitative, and the first two are not. Now I could have another column here, which I would call a label column, and that would just label the students. So I could label them 1, 2, 3, 4, 5, 6, and 7. Now this wouldn't be a variable because it's not answering a question about the students. It's just identifying them with a label. So this table shows all the data from the questionnaire, but it's not arranged in a way that makes it easy to interpret. So next we're going to look at some ways to organize data. So a distribution of a variable gives information about how often the variable takes on certain values or intervals of values. And the first type of distribution we're going to look at is called a frequency distribution. And this shows all of the observed values of the variable and how many times the variable takes on each of these values. So let's look at my chart again, and I'm going to concentrate on this last variable of coins, and I want to fill in this chart for the frequency distribution. So first I want to list all of the values or all of the numbers that I see in this column, and I'm going to do that in increasing order starting with 0. So I see 0 is the lowest number I see in that column. The next number I see is 35, then 50, and 76, and 215. So those are all the numbers I see in this column listed in increasing order from 0 up to my highest value of 215. For the frequency, I'm just going to count how many times I see each value. So I see 2 zeros, so that frequency will be 2. 235, so that frequency is 2. There's 150, 176, and 215. So that fills in my frequency distribution chart. So now it's a little more nicely organized. I can see what all my values are in increasing order and how many times that value occurs in the chart. The next type of distribution is very similar. This is called the relative frequency distribution. Again, it shows all of the observed values of the variable, and this time we're calculating what percentage of the time each value occurs instead of just counting. So as a reminder of how we calculate percentages, the percentage of individuals is going to be equal to the number of individuals who have that value divided by the total number of individuals and then multiplied by 100. So let's go ahead and fill in this chart. My first row is the same. It just lists all of my values in increasing order. For the second row, I'm going to calculate my relative frequencies. So for the value of 0, I have 2 individuals who have value of 0, so my percentage is going to be 2 divided by 7 total individuals, and then multiplied by 100, and that equals 28.6%. And here I'm going to round to 1 decimal place, so I can fill that in my chart, 28.6%. My next value is 35, and I've also got 2 individuals who had a value of 35, so that's the same calculation. 2 divided by 7 times 100 is also going to give me 28.6% here. For the value of 50, I've got 1 individual who had 50 cents in their pocket, so that calculation is going to be 1 divided by 7 times 100, and that's going to be 14.3%, and I'm rounding to 1 decimal place again here, so 14.3%. I've also got 1 individual with a value of 76, so that is the same calculation, 1 divided by 7 times 100. It's also going to give me 14.3%. For 215, I've also got 1 individual with that value, so it's going to have the same relative frequency of 14.3%. So now I've filled in my chart with the percentages of individuals who have each value. A good way to check your relative frequency distribution is to add up all of your percentages, and they should add up to about 100%. So let's do that. We'll have 28.6 plus 28.6 plus 14.3 plus 14.3 plus 14.3. If I add all of those up, that's going to give me 100.1%. So that's very close to 100%. And it's a little bit off because I rounded to 1 decimal place up here. So if I had taken the exact percentages here and added them up, it should be exactly 100%, but because I rounded, it's a little bit off. Okay, we've got one last type of distribution to look at. This is called the grouped frequency distribution, and it breaks up the values into intervals and then counts how many values are in each interval. So in my example here, I've broken it up into 50-cent intervals. My my lowest interval is from 0 to 49, and that's going to include my smallest value, which is 0. And then my highest interval is 200 to 249, and that includes my highest value, which is 215. And then I've just included all of the 50-cent intervals from 0 to 49, 50 to 99, 100 to 149, 150 to 199, up to 200 to 249. And now to fill in my frequency, I'm just going to count again. So I'm looking for all of the individuals whose value is between 0 and 49, and that's going to include these 2 zeros and these 2 35s here. So that will give me a frequency of 4. For 50 to 99, that's going to include the individual with 50 cents and the individual with 76 cents. So that frequency is going to be 2. I don't have any individuals who fall into this interval from 100 to 149, so its frequency is going to be 0. I also don't have any individuals with 150 to 199, so that frequency is also going to be 0. And I've got one individual between 200 and 249, so that frequency is going to be 1. Alright, so that fills in my grouped frequency distribution, and even though I have zeros for frequencies in these two intervals, I didn't skip any intervals. I included everything from the interval that includes my smallest value up to the interval that includes my highest value. So now that we've got some numerical ways to organize data, we want to look at a graphical way to organize data known as a histogram. So a histogram is a way of displaying the data that you saw in the grouped frequency distribution. So let's look at an example of that. So again, I've copied my table from the student questionnaire here, and I'm looking at the variable coins. Now, a histogram is going to be a bar graph where I've got my intervals across the bottom here, and each interval takes up the same amount of space horizontally. And then above each interval, I'm going to draw a bar where the height of the bar is given by the grouped frequency, or the count of individuals in that interval. So if you remember, from 0 to 49, I had 4 individuals that fell into that range, so I'm going to draw a bar here on my chart of height 4, and 4 was my highest frequency in my grouped frequency distribution, so my vertical axis here goes up to a height of 4. Alright, so that's my first bar. From 50 to 99, I had a frequency of 2 in my grouped frequency distribution. I had those 2 individuals, so I'm going to draw a bar of height 2. For the next 2 intervals, I didn't have any individuals who fell into those intervals, so I'm going to have a bar of height 0, or just a line here. And then from 200 to 249, I had that one person fell into that interval, so I'm just going to draw a bar of height 1 there. So that gives me my histogram as just a visual way of representing the data that I had in my grouped frequency distribution chart. And this is, here it is a little bit nicer so you can see it a little bit better. So let's look at another example here. So this chart shows the percent of adult population of Hispanic origin by state, and this data comes from the 2010 census. So what are the individuals in this chart? Well, the individuals are the states. And we've got a label column here that labels the states with their names. And then the variable is the percent of population of Hispanic origin. So the variable is percent. So first, before we're going to make a histogram for this chart, but before we do that, I want to notice a few things here. So my state with the lowest percent of adult population of Hispanic origin is Maine with 1.0%, and the state with the highest percent is New Mexico with 42.3%. So I want to keep that in mind when I'm going to make my histogram. So next we're going to go through the steps to make a histogram. So first I want to choose my intervals or classes, and I want to divide the range of data into some reasonable number of classes of equal width. As a general rule here, somewhere between 5 and 20 is a good number of intervals or classes to have. Now remember that our data ranges from 1.0 to 42.3%. So one way I could choose my classes is I could break it up into 5% intervals, and I've done that here. So my lowest interval is 0 to 4.9%, and that includes my smallest value of 1.0. And then my highest interval is 40.0 to 44.9%, and that includes my highest value of 42.3%. And this divides it up into 9 classes, so that's a good number to have. So once we've chosen our intervals, I want to make a grouped frequency distribution. And I've already done that here in this chart. So for each of my intervals, I've just looked at my original chart and counted how many states fell into that interval. So for my lowest interval of 0.0 to 4.9, I counted 22 states that were in that range. And then for all the other intervals, I just also counted up how many states were in their ranges, and that fills in this chart here. Once I've got my grouped frequency distribution, I can use that to make a histogram. So I'm going to make a chart, and the heights of the bars in my chart are going to be given by these counts in my grouped frequency distribution. And if I do that, I'm going to end up with this histogram here. So notice my first interval here is 0 to 4.9, and that bar has a height of 22. My second interval is 5 to 9.9, and that's got a height of 15 because I counted 15 states that had populations between 5.0 and 9.9% Hispanic. So I've got most of my states fall into these first two intervals I can see from my chart, and then it kind of trails off to the right here, and then I've got a gap, and I've got just one state in this last interval here, which is New Mexico with the highest percentage of population that's Hispanic. And this could be an outlier. So an outlier is a point that is outside of the rest of the data. So it looks like my data is, I've got a high percentages here, and they kind of trail off, and most of them fall off by 35%, but I've just got one state that's kind of out here on its own, and that could be an outlier. Alright, so that's my second example, and then things that you should know for this section. You should be able to identify individuals and variables in a data set. And then you should be able to create distributions for a given variable. And we had 3 different types of distributions. The first type is a frequency distribution, where we just counted for each value the number of individuals. And then the relative frequency distribution, we found percentages for each value. And then the grouped frequency distribution, we counted in intervals of values. And then you should be able to create a histogram to represent data, and you will do that from a grouped frequency distribution. So those are all the things that you should know from this section.